Okay, physics time, and it is physics. We're talking today, this is the physics class about where we talk about physics. The chapter in your book is titled About Science, but physics is a kind of science, so we're going to talk about both at once, okay? So this is physics. What is science? Someone had briefly said that science is a way of what? Finding out about the world? Is that what you said? Knowing about the world. A way of knowing about the world. I like this because Justice did not make it up. He copied it straight out of the book. I like it though because the word science comes from the same root as the word omniscient or omniscience. You know that word. Omniscience means that you're in a state of all-knowing. Yeah, omniscient means all-knowing. You might joke and say that your mom is omniscient when she figures out something naughty that you've done, which does not apply to you because you're both not naughty. But omniscient, omni, meaning all, and science, meaning knowing. And in our modern usage of this, we use science to mean it's a way of knowing. It's not the act of knowing. It's not the fact that we know. It's not just the facts. It's not memorizing the order of the planets. It includes that, but it isn't that. It is not memorizing King Philip came over for green spaghetti or whatever. That's not the point of science. Science is not just a body of knowledge. It is primarily a way, I'm going to put in here in parentheses, not just facts. It involves facts. You have to know some stuff, but it is primarily a way of looking at the world. It's a way of perceiving. When I started, I can't remember if it was physical science or chemistry. There was the same teacher for both, and when in like the first week of class, he was talking about scientific method, and he said, if you're a smart person and you want to find out about the world, you ask questions and you make observations and you draw conclusions based off those. If you're a stupid person, you eat it. And that is science. Science is about a way of perceiving the world. You know, some people are very comfortable, I'm not pointing fingers, but some people are very comfortable just living their lives, you know, like breakfast to lunch to dinner. They just eat it. That's all they do. They go to a job where they eat their lunch to make money so they can buy more lunch so they can go back to their job. And that, to me at least, is not a fulfilling existence. And part of what makes existence fulfilling, in my opinion, once again, this is opinion, is a way of looking at the world. Like to be curious and interrogative of the world, you know. What kind of tree is that? Do you see the tree? What kind of tree is that? Yeah, the one right here between us and the flagpole. You don't know. Yeah, I don't know. I don't know what kind. I do know what kind of tree that is, but a person just walking by that tree, or even just using it for shade, or a squirrel using it for food, is not, in my opinion, once again, this is just my opinion, is not getting the fullness out of life that they could if they were wondering. And I don't just mean about trees, but to be curious about the world is the point of science. So we have here curiosity. And that gets me to my idea of the scientific method. And I don't claim invention of a lot, but I like this succinct kind of distilled version of the scientific method that I relay to kids. Step one of my succinct version of the scientific, I use different verbs for this variously, but step one is observation or a question or something like that. Step two is investigation. And step three is conclusion. And you've seen scientific methods that are 6 steps long or 7 steps long or 12 steps long or 4 steps long. I think they all get at this, that there's something about the world, something about the world I'm curious about. If I phrase it as a question, what kind of tree is that? Or if I phrase it as, look at this cool bug or whatever, that's an observation. Something about the world I'm curious about. And it's not just the things that we normally think of as science, by the way. You might see someone drive by in a cool pickup truck like Wade Riggs, and it's like, you're like, wow, look at that sick cracked windshield. That's great. What kind of pickup truck is that, you might ask? And that's an observation. It's not always just about the natural world. Sometimes we use science, strictly speaking, to mean just about the natural world. But I'm positing that we're using a scientific method in our brain anytime we're doing something even like, girl, where'd you get that dress at, or whatever. That's an observation. An investigation, then, I'm not going to put in quotes yet, but let's do these two different questions. One is, what kind of tree is that? Two, let's actually have three different questions. Two is, let's say, what kind of pickup is that? We'll use Wade's pickup as an example. And three, we'll say, does phenylephrine work? I'm going to write this word over here, phenylephrine. Phenylephrine. This is a drug that you probably taken that is used as a sinus decongestant. If you have allergies, you've probably seen, if you take Tylenol allergy or Tylenol sinus, it probably has this phenylephrine in it. So we have three questions. One is, what kind of tree is that? Two is, what kind of pickup is that? Three is, does phenylephrine work? Okay? Those are all questions that science can answer. And in each of those cases, we're going to have a different kind of investigation. If you actually, I don't know your life, but if you actually wanted to know what kind of tree that was, what would you do? Google it. You might take a picture and see if Google can do the reverse image search. You might say, you type into Google, tree with lobed leaves. That's if you know that vocab, where the leaves look like on that tree. They look like this, and those are called lobes. You might, if you were really interested, you might find someone, me or Ozzo or Mr. O, you might say, hey, what kind of tree is that? Like you relay the question, and that's a kind of investigation. That is research, or even asking a person a question is investigation. If you want to know what kind of pickup that is, what would you do? Like imagine you were for some reason interested in Wade Riggs' pickup. Yeah, you'd wait till you saw Wade the next time and you would ask him, and that is an investigation. If you are GlaxoSmithKline or whatever pharmacy produces phenylephrine, big pharma, and you want to know, does phenylephrine actually work? This is related to, I've seen for a while now, there's research. There's real confusion in the FDA, the Food and Drug Administration, if this drug has any use at all. Like the trials they've done show that even at 4 times the doses that you get in the normal medicine, it does nothing compared to placebo. And so they're considering doing clinical trials to see, is this an effective? So how would you do that? Is it good enough? If you're CEO or head researcher for GlaxoSmithKline, the pharmacy company, could you just go to Google and type in, does phenylephrine work? Would that be a good way to solve that investigation? No. You're going to have to run clinical double-blind trials with placebos, with animal testing probably, over the course of dozens of years. And that's science too. Everyone agrees that's science. Everyone says, oh, clinical trials, that's real science, that's hard science. But my position is that these other kinds, what kind of tree is that, which you're just Googling, what kind of pickup is that, which you're just asking Wade, you're doing the scientific method whether you know it or not, unless you're just the mouth with legs going through your life eating and doing nothing else. Everyone's doing an investigation. And then your conclusion in each of these cases. We don't know what the conclusion of this will be. I would guess they're probably going to pull it from the shelves, not because it's dangerous, but because it does literally nothing. The conclusion of this is Google will tell you this is an oak tree. That is an oak tree. I think it's a white oak, but don't quote me on that. It's definitely some kind of oak tree. And for Wade Riggs' question, we could holler him in here. I'm pretty sure it's a Ford Ranger with a cracked windshield, but we could get him in here and he could tell us all about it, I'm sure. Each of those things has a conclusion. That's science. That is a way of knowing. It's not just knowing. It's not just memorizing the different drugs and how to spell them. It's not just memorizing the different trees and the shapes of their leaves. It's certainly not memorizing what car everyone drives. It's a way of looking at the world. Your book talks about how physics is applied math. There are different ways to apply math. Mr. Snitley told you, math is the universal language, isn't it? You've heard this before. I'm sure you've heard this rhetoric from Mr. Snitley. There are different ways to apply math. Business math You know, like when you go to McDonald's and how much tax are they going to charge you on the 4 Big Macs you order? Can you eat 4 Big Macs, do you think? Tatum, have you ever eaten 4 Big Macs at once? I think I could pretty easily eat 4. Oops, my little... but how much tax is applied, that's obviously math. A way we apply math in the natural world is in physics. Things like, what frequency of light is that? Or how fast is that thing going? Or how do these particles interact? Or all those questions we saw yesterday, like, what is a circle? Those are all math questions about the world. So physics is applied math. The next heading in your book says the scientific attitude. What is the scientific attitude generally? What would you say? A good scientist carries an attitude of curiosity, unbiased, as best you can, right? Someone's making just a literal shed load of money off of this. They're producing this extremely cheaply and selling it relatively expensively. Someone's making a lot of money. It will be very hard for that person or group of people not to be biased with the results of these clinical trials. But a good scientist is unbiased. Okay, let's talk now about, and you've heard these things before, but a scientific hypothesis, theory, and law. Are these all the same thing? No. The fact that I'm asking that question. What's a hypothesis? Give me a definition for a hypothesis that you're comfortable with. Yeah, we start with an educated, I'm going to put it in quotes, an educated guess. It has to be, though, must be what? You see this on your lab guide that I've given you. You see this in your book. It must be, remember? Disprovable. We never, let me repeat this after I say it, we never prove anything in science. We never prove anything in science because we can't factor for all the different iterations of that thing. We never prove anything in science. We use that word pretty flippantly in our normal life. Like I could say, oh, I've proven that this tree is an oak. But there's other kinds of that tree. There are other trees. Have I shown for every case in the entire universe that that tree is an oak? For all time that tree is an oak? No. So we can't ever take into consideration all of space and time, and so we never say anything's proven. We can only ever disprove or uphold a hypothesis. But they must be disprovable. So I'm going to ask, some questions are just not scientific. They can't be dealt with in science. We use some kind of silly examples. What kind of pickup is that? What kind of tree is that? We used a fairly serious example. Does phenylephrine work? Is that disprovable? Can we disprove that phenylephrine works? Yeah, you can think of a way. Maybe it won't happen, but you can think of a way that it would be disprovable. Is the question, yellow is the best color, which is my opinion, is that scientific? No, it's not disprovable because it's a matter of opinion. Donald Trump was the best president. Is that a provable hypothesis? Or sorry, a disprovable hypothesis? Yeah. No. Is Donald Trump was the worst president a disprovable hypothesis? No. So we can't have opinions be a scientific hypothesis. A rough one is there any such thing as God? That is a very difficult thing, but we say that is not disprovable, and so it's not within the realm of science. It's almost like a cop-out, but that's not within the realm of science. It's just completely separate from science altogether. How did the universe begin? Well, that's not a hypothesis, it's a question. But if we say the universe began with the Big Bang, is that disprovable? Probably not. We can gather a lot of data. If we specify within that hypothesis things like at the beginning of the universe, the temperature of everything was X degrees Kelvin, or X degrees Celsius, which I don't know the number. But that is a scientific hypothesis. That could be disproven. There would be evidence that can be piled up within that. But kind of vague things like that. Or things like the Mona Lisa is Leonardo da Vinci's best painting. We can't have judgment words within it and have it be a scientifically disprovable hypothesis. They must be within the realm of physical reality, so supernature doesn't count. Is my house haunted? That's a question. My house is haunted is not a disprovable hypothesis because that's not within the realm of nature. My house is infested with black widows could be a scientific hypothesis because that could be disproven. But if it's infested with ghosts or not within the realm of science. So then what's a theory? If a hypothesis is, when we use this word, when Yo Mama uses this word, she usually means this scientifically. If she says, I have a theory that your brother pooped his pants. I don't know where that came from. I'm sorry. I have a theory that we're going to have to go out to eat tonight. She doesn't mean theory in the scientific way. She means hypothesis. Because what is a theory?
A theory is a proposed idea that...
An explanation, okay, that encapsulates, let's put that, encapsulates, we got two long words now, all available evidence. You are exactly right, Tim. It is not proven. Nothing can be proven in science. But theories are those explanations that take all of the evidence into consideration and provide an explanation for that phenomenon. The theory of evolution takes all the available evidence about biological change and incorporates it into one disprovable, but as far as we know, correct theory. The theory of gravity. Much trickier, because we're going to talk about the law of gravity in a second. But the theory of gravity is, why does gravity behave this way? The main question for theory is why. The current theory we have of gravity has to do with things like Higgs bosons, and they explain, with all available evidence from particle physics and from mechanics, why things are gravitationally attracted to each other. That's a difficult question. That's actually one of the current problems in physics, is why does gravity work? Whereas the law of gravity is just a statement of fact. The law of gravity is that massive objects are attracted to each other. Does this have mass? This is a marker. Does this have mass? Does planet Earth have mass?
Yes.
Are those two things attracted to each other? So what should happen? It will be attracted to planet Earth, right? That's the law of gravity, is that those two things are attracted to each other. The theory of gravity is, why are they attracted to each other? Much, much trickier. The law of biological adaptation, to use our other example, is that organisms change to meet their environment. That's observable fact. We see that happening. That's a law, a biological law. The theory, why does that happen? The theory of evolution is much more, has to encompass much more evidence and is providing an explanation instead of a description. So then what is, and this is the last thing, what then is the role in society, role of religion and art? A very common mistake, I think especially among Americans, or maybe among Americans today, is that a person must either be oriented in their life scientifically or religiously, and that there cannot be either. But it's actually very freeing to realize that when we have questions like, is there God, or why are we all here, or how did the universe begin, the fact that those are not scientifically valid, that they are not disprovable, is actually very freeing, because everything relies on some amount of faith. When you take a step, you're doing so in the faith that gravity will be there, that there will be gravity to pull you down all the way, or that the normal force will hold you up. Everything is faith to some degree. The role of religion is to kind of consolidate and conceptualize and delineate the way of faith. So this is about belief, a way of believing. A lot of times we think about belief as just opinion, and a lot of times we think about the ability to believe facts, and that's just not the way it is. Someone, I can't even remember who it was, but someone yesterday asked me, do you believe in global warming? And it doesn't matter, because my opinion isn't going to change whether or not there is global warming. So that's not a useful thing to have a belief about. Sure, we could provide evidence, probably from both directions, and there is scientific hypotheses about global warming that need to be considered, especially when we think about our children or their children, etc. That those things need to be taken into consideration. We shouldn't just ignore it. But the belief in that capacity is not very useful. Whereas for religious things, the belief is it's useful, but it's even rational. A lot of people think about religion as an irrational thing, that it's just almost fairy tales, and that's not the case either. It's also very common to think that science itself is a-religious. It has been for 400 years. That means like the way of knowing about the world, we try our very best to remove belief from it. But that doesn't mean that a scientist as a human being has to be a religious. Does that make sense? In fact, many, I would say probably even most scientists, have religious beliefs. How they squish those things together with their scientific facts is usually fairly easy and usually not a problem, but how they do that is their own business, and that's the point of religion. Science as a body is a-religious, but that doesn't mean scientists are a-religious. And remember that even scientists who are at least claiming atheism, that itself is a belief system. The belief in no God is a belief, right? So all human beings rely on this. The reason I'm saying that is because this is important. It's every bit as important as all of this, but it's not within this. And since this is a science class, physics, which is applied math, we don't deal with the things of belief. That doesn't mean they're useless. They're just not within the realm of science. Do you think I've hedged this bet enough that we can move on? Similarly with art, some people think that art, which is about expression, is necessarily more useless or something than science because it doesn't provide a tangible benefit to the world, you could say. But that just isn't the case either. Human expression, just like belief, is a valuable and inextricable part of the human condition, that we all need to be able to express ourselves. Everything is art. Mr. Snitley, I'm not trying to throw him under the bus, and this is being recorded on YouTube for the public to see, but he claims that he doesn't like art. But even when he builds a derby car, that is art. When he does math, there is art in that. That is expression, and every human being needs to express themselves. Every human being needs to believe. But again, these things are not within the realm of science. Not because they're useless or bad or unnecessary, but because they just aren't disprovable. We focus on this, and we use this math as the tool to prove or disprove, to disprove or uphold our hypotheses, which can then become theories. Let me make sure that I've got everything. Do you have questions about this? When I say I hope I have sufficiently hedged my bets, I know it's very easy to get into, I wouldn't even say arguments, but like opinion struggles with people, especially about these two things, because people sometimes operate under the misconception that science should include those. But we leave it out for the benefit of both. It's kind of like the separation of church and state in America, that we leave out state from the church. Churches aren't taxed, and we leave out church from the state. There aren't laws governing religious items in America, and that benefits both. Both things are benefited by that arrangement. Same thing here. We don't talk about our beliefs and expressions in science because we have other business to do, basically. All right. Any questions? Let me just do one run over to make sure I got everything that is in the summary. All right.